Hi everyone and welcome to the session. Unfortunately we cannot meet in person, but I'm sure there will be a next time. I will still try to give you the best conference experience I can. My name is Matt, I work at JetBrains, and today I will talk about building CI/CD pipelines with NUKE. Before we jump into live recorded coding, I will give you a little bit of background. First off, NUKE is a build automation tool. But what does build automation actually mean? In its most simple form, build automation covers tasks like compiling a solution, packaging everything up into NuGet packages and pushing them to NuGet.org, or just publishing a website. However, over time, and the more tasks are being involved, build automation can get quite complex, as we can also see in this picture. For the .NET ecosystem, there are quite a few options for build automation. The one I started with, and probably everyone is using to some extent, was MS-Build. MS-Build is based on an XML format. Project files are the files which we put our logic in. For more complex things, we can also escape into something called task assemblies and write actual C# code. However, this whole ceremony was never really feeling any handy. At my previous company, at some point, we considered other alternatives. For instance, Psaki, which is based on PowerShell, or Fake, which is based on F#. However, the issue that we had here was no one in our team was either fluent in PowerShell or F#. It was just an unfamiliar language to us, and basically would put another requirement on our team and new team members maybe even. Then there was also Koch, and Koch was really promising because it had a C# DSL. However, after using it for quite some time, it turns out Koch is still a scripting approach and therefore doesn't really integrate well with existing tooling, like IDEs for instance. So at some point I decided, let's just build my own build automation framework. And that's what we will look at now. The first thing we will look at is how to set up your solution with NUKE. For our demo purpose, we will consider a very simple solution. So in this case, I have a library project along with three test projects. And the first thing we do is to install the NUKE global tool. The global tool will help us with the basic setup, but also has some other benefits we will look at very shortly. So after the global tool has been installed, we can just call NUKE. And since our solution is not yet built with NUKE, we're going to get asked if we want to do so. We will just accept with yes. Now the wizard will walk with us through some questions, and we can answer mostly the, let's stick to the defaults. We will call the build project _build. We will put it in a build subdirectory. We can choose between different versions, including the latest release, latest local, but also latest pre-release, for instance. And we can also choose to add it to an existing solution. So in this case, I will just use the Fwdays solution. And there are also a couple of more questions we can answer, but at this point I will just stop and complete the setup. Now if I unfocus the terminal, Rider will automatically reload our solution and we can see that a build project has been added. This will work similarly with other IDEs, of course. If we look into the changes which have been applied in our VCS, we can see, now we'll just cover the most interesting ones. The .nuke file is basically a marker file for our repository, which says this repository is built with NUKE. Then we also have the build project, of course, and we can see it's of course using the .NET Core SDK. It also works with the .NET framework, but I would not recommend that. We have two bootstrapping files in PowerShell and Bash. Those two files will ensure that on our machine the .NET Core SDK is actually installed, so we don't need to bother about that. We also have a build.cmd. This file is really interesting since it works actually cross-platform, and there is the default build implementation, and we also can see that the project has been added to our solution. Now if I call NUKE again right here, and let's call it with --help, we can see this time it already runs our build. And after a brief moment, we should see our help dialog. So first we can see the logo, then the version, and we can see the available targets, along with a couple of parameters that we can pass. Now back to what I said, the global tool actually also helps us with shell completion. So for instance, we could type NUKE and then CO and tab, and we complete to compile. Now we could also continue and specify the configuration, tab again, it will complete to configuration, and even to possible values that are passed to as parameter values. So in this case, we could also complete to release. So that's it. Our solution is all set up and we can continue. In this next part, we will learn how to get started with actually writing our build. So let's get back to our pre-generated default build. The first thing we will notice when we look at our build class is that it defines a static in main method, which is because this is just a console application. So in this main method, we just delegate to NUKE as a framework to execute our build. And we can also define a default target to execute if we just invoke NUKE as a command. We can also decide to add multiple targets as default targets or none at all. We can choose. If we continue looking here, we can see that 3 targets have been pre-generated, which are clean, restore, and compile. So one interesting difference to other build automation tools is that those targets are actually defined as symbols, as real properties in C# language, which also leads to the fact that if we decide to rename compile from here, and I will just add a 2, then also the actual definition gets updated, and we never run into issues where we accidentally have a typo or anything. So I will just revert that change, and now let's do a simple hello world example, and I will use the logger to write an info message, and that's right, I'm building with configuration. And now we can go back here and execute our build. And after compiling our build project, first thing we see is that we have a little summary telling about all the targets that have been executed along with their duration and status. But we can also see our message has been printed. So let's go back here, and one more interesting fact is, since this is just a console application, everyone knows how to debug that. For all the IDEs, there are extensions which make debugging a little bit or even more easier. And in Writer, for instance, we can just use the Alt-Enter shortcut and say we want to debug the compile target. And I will also add a breakpoint right here. And now after the debugger has been attached and everything is running, we can see we just stop at our compile target, and we can also look and investigate how our build object actually is structured. So we can see, for instance, that configuration was initialized with the value of debug. So that's all for the hello world example. Let's dig into something more interesting. Everyone has experienced that. We are passing a relative path, but our tool is expecting an absolute path, or we are in the wrong directory. So in the next part, we will look at how to do path constructions with NUKE. To illustrate path construction, we will implement the clean target. Going back to our solution, we can see that all our projects are located underneath a directory called source. And usually, if we build our projects, we end up with some kind of artifacts, like for instance, the bin and obj folder. So let's clean those out. Our NUKE build base class provides a property called root directory. This directory is the same directory where the .nuke file is located. And from this directory, we can make use of some globbing mechanism to grab our obj and bin folders. So first, we will do source, then a wildcard, and grab the bin folder. And from here, we can continue and do a for each and say delete directory. Let's execute that. And after a moment, we can see that all our bin folders have been deleted. Now we want, of course, to do the same for obj, and we can do it this way, but we can also do it that way. Source by specifying multiple patterns and execute it this way. However, this is not the best we can get because we have this duplication of the source directory. A better approach would be to introduce a new property of type absolute path, and we will call it source directory. And we will implement it from the root directory, again, where the .nuke file is located, and then use the division operator and append source. So this division operator is an abstraction for the path separator. So depending on which operating system we end up with either slash or backslash. And also, I hope everyone noticed, this is of type absolute path. So we will always deal with absolute paths if we stick to this schema, and we'll never use relative paths. So and now from here on, I can replace this with the source directory, and I remove this part. And if I execute this again, so previously we deleted the bin folders. Now, since they're not there anymore, we will only delete the obj folders, but we cleaned out our artifacts. Of course, cleaning out our solution isn't going to get us far. We need to do some real work, and for that we will use tool invocations. Tool invocations are performed using dedicated tool task classes, and for the restore target we're going to use the .NET task class. So right here I will call .NET task and then call the .NET method. And this is just a wrapper to invoke the .NET CLI. So I can call restore and pass our solution. Complete that statement, and that would be equivalent to calling .NET restore fwdays.sln. One thing I tend to do here is to import static members just to make it a bit more readable. We can continue with the compile target, and here we will use a different approach. We will use the .NET build method, and this would be equivalent to calling .NET build. And if I invoke the quick documentation for .NET build, then we can see this summary explains the .NET build command, and it's actually the very same documentation that is used on the Microsoft website. We also have a link to the official website, and in the remarks section we can see that this is a CLI wrapper with a Fluent API, and we are allowed to modify certain arguments based on properties. So for instance, the project file with the project file property, or the no restore flag with the no restore property. And how this works is by starting a lambda expression. On the next line we can start calling methods like, for instance, set project file. Set project file, and here we will pass the solution. On the next line we can, since we have been restoring already, compiler is dependent on restore, we can enable the no restore flag. And here we can also see, since this is a flag and basically a Boolean, so we can pass it or not, we have several modification methods, builder methods basically, to modify that flag. And we will choose to enable no restore. Continuing, we can also pass the configuration because we have the configuration parameter right here. So let's pass the configuration. And just to make one more showcase, we can also set the verbosity. And verbosity, as you probably know, has a defined set of possible values. We can also tell that from the signature right here. And if we invoke the smart completion feature, we can see that we're going to provide it with all the possible values, and we can just choose one of them, and we will go with minimal. So just to complete our invocation, that will be Fwdays solution -- no -restore. Configuration is debug probably in this case because we are on a local build, and we also pass the verbosity of minimal. So, and that we can just execute. Let's wait. So, and for the restore target, we can already see here's the invocation, the .NET CLI. Now the compile target is executing. And the great thing here is for every command, the actual invocation is going to be logged. So we can just go ahead and copy that, maybe even put it somewhere else. And also we discussed the absolute paths already. And as you can see, we get the absolute paths here as well. And therefore we can just invoke the command from anywhere we want, and it will work. And we can see the configuration is passed, the -- no restore flag, and the verbosity. Done. So far we have only looked at the .NET tasks, but NUKE provides a lot more APIs to all the well-known and commonly used tools in the .NET ecosystem, including MS-Build, NUnit, XUnit, NuGet, Paket, OpenCover, Report Generator, Octopus, NSWAG, NPM, Docker, the list goes on and on. As of today, there are roughly 250,000 lines of code responsible for those wrapper APIs. How is that possible? In NUKE, we make use of something called specification files. Those files contain information about executables and how they can be found, for instance, on the path or in NuGet packages. Also, it contains information about commands that can be invoked, along with those parameters that can be passed. Of course, with their type and help texts. From those specification files, we then simply generate the C# code that will provide the API. So as a user, really only see the nice and clean wrapper API. This approach also ensures that for new features that we add to the wrapper API, we can just regenerate it for all the tools. We will look at one of those two features in 1 second. To show these features, we will follow along and implement a test target. For this, I already prepared a couple of new properties, which are test projects, which basically grabs all the projects starting with test from the solution, and also a test results directory, which uses the path construction feature again. Also, our test target is dependent on the compile step. As we remember, we have a total of 3 different test projects. I also prepared the invocation already. And this is the naive approach, basically. And as we can see, we want to execute .NET test 3 times, and then supply the project file, the logger file, etc. One thing that's pretty interesting here is that part of that invocation for all the 3 is different. Meanwhile, another part is the same. So there's a more elegant way instead of using the for each. We will first remove the for each for now, and now just cut the part that is different. So let's do that. At the end of that invocation, we're now using the combine with extension method, which is basically used to provide some kind of combinatorial way of those settings files that we pass to manipulate the invocation. So to combine those common parts with the different part, we will now pass the test projects. As a second argument, we will get a lambda expression again, and we will get as first parameter the settings file, which is basically what we created here, along with the value which is coming from those test projects. So now we will use the settings file again, and here we can then just paste our different arguments, which are different, and then replace the test project or previously test project with our v value. Let's reformat that, and that is basically the same as we had before with the for each statement. Now, what is so special about that? For first, I think it's much cleaner. As a second, we also can provide more arguments here, which are, let's do this again. We can define a degree of parallelism. In this case, the default is 1, but we can also define to complete on failure. So for instance, if one invocation fails, then we can decide to continue with invoking all the others. A second great feature about this Fluent API is that we can use when call. So for instance, if we decide to, let's say, to only collect coverage data if we are running in with the release configuration, then we could do it like this. So we will say when configuration equals configuration release, only then please do enable collect coverage, and let's reformat that. And here in this case, this actually requires an equals. But now you see we have a very nice and clean way of manipulating or modifying our actual invocation. And even more interesting is that those two patterns, the when and combine with, can be nested with each other. So especially here, actually it's necessary to do that, but we can just copy that and paste it here, add a new parenthesis. And now, of course, we have it correctly assigned that the coverlet output is also only set when our configuration is set to release. We will look at that feature in a moment again, but for now, that's it about the test project, about the test target. One more important topic in build automation is how we can version. One more important topic in build automation is how we can do versioning with our artifacts. Also, we will look into how to pass parameters into our build and how to make requirements for certain targets for that. So now we will just implement our pack target. And as always, I already prepared something. So in this case, what we want to do is to invoke something like .NET pack, then pass our project, our library project, along with a version we yet have to define, and the output directory. So let's start with the simple part, which is set project, and from the solution we will get our project, which is called library. And we can also set the output directory to output directory, another property. Now for set version, we need to define the version. And what do? One of the common tools used for producing semantic versions is Git version. Git version makes use of our Git commit log so that for each and every commit we get a different semantic version. It is also based or can make use of the commonly known Git flow and GitHub flow, which are basically used to have a defined way of producing major, minor, and patch versions. So, and in order to use Git version, I will create a field like that. So we have a field called Git version. It has a type of Git version, and it is attributed with the Git version attribute. So that looks very funny, but usually I also add the read-only modifier, because this is initialized by NUKE before any of the targets will start. And afterwards it should be really read-only. And now we can make, we can just use the Git version object and pass the NuGet version v2, for instance. For this to work, we actually have to make a modification to our build project. And in this case, we need to download the Git version tool. Package download is a new feature of .NET Core 3. I think it was available before as well, but not sure in which version. But this basically tells the .NET CLI to download and NuGet to download that tool in that particular version, but we won't have any assembly reference or something. So this is just to ensure that this tool is available in our global NuGet package cache. And now if we go back here and we invoke our pack target, then hopefully we should see that some version is supplied and we can actually pack our target. So no, what's wrong? In this case, because Git version is available in a couple of different frameworks, we need to set the framework right here. That's probably a bug, but can be fixed pretty easy. So let's try this again. And now we can see Git version has been invoked. It has gathered the information from Git version, and it was passing a version of 0.1.0 or 0.1.0. All right, so we have a version actually. A second part for that is we want to implement, let's see where it is, the publish target. And for that, I also prepared to gather all the packages. We again used the path construction way to gather all the NuGet packages. And here we see we use the .NET NuGet push task. We set the source to our mygit source. I probably won't look into that because it's kind of funny to show you that, even though it's recorded. But what we also see is, of course, again, the combine with. So we also have the combinatorial way of creating invocations, as we have seen with the test target. But we also want to pass our API key to actually be able and being authorized to push something. And to pass along the API key to our build, we create a parameter. So, or better to say, we could do it also the more elegant way. We can create a field. Let's create a field. So now it's a string, move it here, and then add the parameter attribute. And what happens now if I call nuke help, which will take a second. Then we can see in our parameter list, we actually have the API key mentioned, and we can actually see that this build can accept an API key. I can also complete that. So if I call NUKE publish -AP, it completes to API key, and we could provide our API key. Now let's say I invoke this publish target, which should depend on pack. So we first pack and then we try to push. Now what happens, and I think it's probably obvious, we haven't passed that API key yet. So during the publish target, we don't apply any API key, and therefore we should get a where is it? A forbidden message from the endpoint. So, and just suppose that these targets are long-running targets. So in that case, if we just miss to pass the API key, it would be pretty disappointing to wait for a couple of minutes only to realize, oh my God, I forgot to pass the API key. So what we can do instead with NUKE at the publish target is to express a requirement, and we use that with the requires Fluent API, and we can just say we want to require the API key. So this overload uses or we can probably also see it, this overload uses an expression way to decode what field should be not null, but we could also write it in a more other way. We could also write any conditions that we want, basically. So we could also write API key should not be null. But I will leave it like that. And now if I call NUKE publish again, then even before starting the pack target, or actually now it is in a it is in an interactive mode, so it will ask for the API key. But I can do a bit of a trick, so I will just make NUKE think that we are executing on Team City. And then what we see, or should see, is that we are immediately failing. So yeah, the output now looks a bit different, but we can see even before executing any of the targets, we can see that published requires the API key to be not null, and that's just what it is. So, and if we actually provide an API key, let's do it. And I would just do some garbage because this is going to be working, but we won't look at it in more detail. Then we can see pack is executing and also publish. All right. The following section is one of my favorites. Many of the other build tools work similar to NUKE, but when you move them to your CI build server, then usually you only have one invocation, although you have several agents that could run in parallel. This would require much work, manual work from a user. With NUKE, I'm trying to follow a different approach where the configuration files like YAML for Azure pipelines or the settings KTS for TeamCity are actually generated from the C# build implementation. And we will now see how that looks like and what benefits it will give you. TeamCity, Azure pipelines, GitHub Actions, AppWare, all those CI systems have something in common, and that is that they read from configuration files that we commit along with the repository to actually do the execution on the CI agents. NUKE is following an approach where we generate those configuration files from our C# build implementation that we just authored. So in the next step, we will look at how this is done. And with our build class, we go ahead and we will showcase things mostly in TeamCity, but it works with all the others as well. First, what we do is to apply the TeamCity attribute, followed by, for TeamCity, we have to supply on what platform we are going to use that. And now, since we have such a lot of targets that could be executed, we need to define which of them should be executed. And TeamCity has VCS triggers as all the other CI systems as well. So with every commit, we can trigger a build. And in this case, for the VCS trigger targets, we will define the test target and the pack target to be executed whenever we commit something. This way it ensures that we execute our tests and we also check if the pack target still works. So those targets will be executed. Now, especially for TeamCity and Azure pipelines, we have to know that both of those systems are able to run actual build chains. So several targets could be executed on different agents. GitHub Actions and AppWare only work on a single node. But so for this very simple example, to make it work, what we need to do is to define all the other targets. I mean, what we want to do is to execute all the targets on a single node, because otherwise we would need to add more logic to our build to, let's say, if we compile, then we need to grab all the assemblies and push it over to the tests, to the test target. But to make it work in this simple case, what we do is just to define all the other targets as non-entry targets, which means they will be packed together with the actual invoked targets. So I will just mention the restore target and the compile target here. So after we've done that, and wait a moment, we have another one. There's another way, but because remember, we also have the publish target. So in TeamCity, we can also manually trigger a target. And for that, we just have a manually triggered targets property, which we can assign the, let's try this again, publish target to. Now this is already everything we need to do from a C# perspective. The next step is to call nuke-help. And in that case, we're not actually interested in the help, but we need to invoke nuke at least one time to actually generate the CI configuration. And if we scroll a little bit up, then we can also see right after invocation, it had created a TeamCity folder along with the TeamCity configuration files. And now I can look into that, and it should be on the file system, TeamCity, and there's our settings.kts file. And this is actually, or can be, a lot of code. So in this case, it's just a couple of lines, but depending on our build implementation, this can be quite huge. And in a second, I will show you how this looks inside TeamCity. So here we are now in our TeamCity instance. As you can see from the build history, I had a couple of hiccups. I guess recorded live coding does pay off. Now we can see both of our targets have been executed, the pack and test target. And if we dive into the latest build of the test target, then look for build log, we can also see that in the output, Nuke also makes use of TeamCity service messages, so that that the output for targets are being collapsed together. And we have our tests executed right here. Now that was the CI integration, but there's one more thing I really want to show you, and it's about the test execution. So let's look into that again. You may remember that we had 3 different test projects. Actually, only one of them contains an actual test, but for what I'm going to show you, that doesn't really matter. Many times our tests run a long time, and for that time it would be great to actually parallelize that execution. In NUKE, we follow an approach to actually allow you to do that with only very little code changes, and we will see how that works. So for our test project, or for our build project, what we need to do is just to create a new field. And you see it's the common pattern of using same name for all types. So we have a partition attribute, and we will tell NUKE in how many partitions we want to separate things. In this case, we have 3 test projects. We're going to go with 3. Now we have this test partition, and this is also an object that's going to be initialized from NUKE. The only thing we have to do is to that partition to our test project. So we will assign the test partition. And now NUKE knows that the test target needs to be divided into 3 parts. One thing we still need to do is we need to know which test project needs to be executed on which build or which build configuration. And to make that work, we will modify the test projects property. And here we're going to use the test partition, and we are calling getCurrent on that. So the first partition is executed with a number, let's say 1. So that partition will know I will take the first part of those test projects. The second will use the second part, and the third part. Now we have those projects, and since we're already using this combine with and we're passing the test projects, this is actually all we're going to change. Now I will regenerate the configuration, let TeamCity kick in, and then I will see you again. So TeamCity already noticed the change and now converted the previous test target or build configuration to a composite build configuration, now with 3 different snapshot dependencies, which are the test 1 of 3, test 2 of 3, and test 3 of 3. We can see that 2 of the test partitions are already running in parallel. This is the one that started first, so let's check the build log of that one. And build log again. And now currently it's still compiling, which takes a while since I'm also running the screen capture here. But we can see now for the testing part, we are only invoking, let's expand this again. For the testing part, we are actually only invoking the 3rd test project. So we are on partition 3, that means 3rd test project is quite alright. So that was just one example on how you can parallelize things. We could have also used, instead of the assembly name, we could also have used the namespaces, for instance, and use XUnit and NUnit to actually define which tests should be executed. But I hope this was a good example on how powerful NUKE is, how powerful especially the CI configuration is. And I'm currently looking into extending and expanding on that. And I'm finished with my presentation. I hope you enjoyed it, and I'm happy to receive questions now in Google Hangouts. So see you, and thanks.
Yeah, Matt, thank you so much for your great talk, and great to have you on here. How are you doing?
I'm a bit sleepy still. Yeah, but thanks.
Yeah, everyone enjoyed your talk. Thank you again. We've got some questions, and I will start asking you them. And we see that you joined Telegram. Thank you very much. If we have more questions during the day, you can answer them when you have time, okay?
Sure.
Great. We've got the first question from Alexander. Could you tell me if NUKE supports integration with Jenkins pipeline? I mean Jenkins directives such as step, node, stash, etc.
Yeah, so currently, unfortunately, not. That's quite well. How to say? I try to cover the most common ones, of course. With Jenkins, it's also difficult to find a good server that can be provided. But actually, I think implementing that wouldn't be that hard. So I kind of wait for a PR from the community for that. But I do think, I mean, the Team City implementation, for instance, or Azure pipelines, they are pretty small already. I mean, I tried to extract a lot of common logic from that. So I guess it wouldn't be that hard. But over time, there are also other feature requests, for instance, and I hadn't have any time so far to look into that.
Thank you. I will get another question from Alexander. Could you tell me if there are any plans to simplify arrow underscore syntax when you describe a target?
Yeah, I get this question quite a lot, actually, especially when people see it for the first time. This has this has some reasons why it's written that way. So first, to introduce this Fluent API, but also to make sure that everything or most part of that is executed lazily. I do remember I tried to create a new branch where you can basically try to replace that logic and provided that. And this question is also in the FAQ on the website for NUKE. And I think also the branch is linked. So anyone who's interested in trying to come up with a different approach, you're welcome. But I do think that this is the best we can get from that. And I also, well, to be honest, I don't think it's that bad. So while I write targets with NUKE, I usually don't even notice that because I'm much more focused on the executes part. Above, there's a bunch of target declaration things, basically. So yeah, if someone is interested, you're welcome. I still have that branch for easy switch of that part, but I'm not planning to change any of that currently.
Thank you. There is a question coming from Pavel. Does NUKE has some tasks for building, pushing Docker image published to Kubernetes cluster?
Well, if that is, I don't know, let me look at the Telegram chat. If that is related to the Docker CLI, then probably yes. So for Docker, I mentioned that in between. The Docker wrapper API is also generated. And with Docker, it's even more interesting because even the specification file is actually generated from the Docker repository. So that's not something that I wrote. So someone else contributed that. But yeah, we gather the information basically from the Docker repository and then generate the complete API. And I think for Docker, the generated API is also a couple of thousand of lines of code. I can even check that. Let me see if I can see it quickly. Docker generated here. Yeah, it's quite a lot. That's also why the NUKE project itself takes quite a bit of time to actually compile. So the NUKE package is around 10 megabytes, what I think is still okay. But show line numbers. Yeah, for Docker, it's 80,000 lines of code. But as a user, you don't really see that except for having this wrapper API. So it's just a nice way of invoking tools, I think.
Thank you. We have a question from Alexei. What are the top 3 items on the roadmap for NUKE, Matthias?
Okay, very good question. Thanks. So the top 3, I think, yeah. So to start with, since it was also the last topic I spoke about, it will be for the CI integration. What's currently missing is if you're running, especially with Azure pipelines and TeamCity. So you have those targets that are executed on different agents. And this currently behaves a bit different compared to the local execution, because if you change a property in your build object, I mean in the C# code, then you won't see that change on the other agent. And this is probably easy to fix, at least I think so currently. The only thing that we need to do is to provide some kind of serialization that will serialize the state after one agent has finished. And for the next, we will just restore and apply those changes. To keep the state over different agents. And if one target, for instance, created a list, then we could make it possible that the next target has that list available as well. So that is one part. The other is, and I kind of push that in front of me, is to allow parallel execution of targets, even locally. So this idea has lower priority, I guess, mostly because with the CI integration, it is possible to run things in parallel, as we have seen. But it's still something I do plan to do, but it's also not that easy because a lot of modifications have to be made, like capturing output so it's not scattered. And yeah, and the third one, yeah, probably. It's quite a big project already, and I don't always find time to look into the things that are really interesting for me. But one thing that's also a work in progress, basically, is to provide a diagram inside Rider, which then shows a live graph of all the targets that have been defined and how the dependencies look like. So whenever you remove a dependency definition, like for instance, this depends on, then you would see it in a live graph and could follow along and just get an idea. Even if you just open a solution where a NUKE or where NUKE is used to build, you would just get a very quick overview about what targets are actually available. Yeah. So those are the 3 things that are probably most interesting for me, but a lot of other issues also in the bug tracker, of course. So
thank you for them. We've got 2 more questions, but we're running out of time. So if you could answer them in our chat, that would be perfect. And maybe there will be some more questions. So if you can do this, we will be glad. So
yeah, sure, always. Thanks also. Thanks.
Thank you, Matt, again. And if you could join us in Zoom discussion, we will be glad to see you there too during lunch break. And have a great day.
Yeah, just one note about that. I won't be there for the full time because I have another presentation today, but I will be there for some time.
Thank you. Thanks. Thank you for this. Thank you for dedicating your time.